All right, now let's look at case 2 of partial fractions where we have repeated linear factors. So, similar to 21 through 25 of your homework. So here we have a repeated linear factor. So we have to break up that linear factor into every power less than m. M here is 2. So we're going to break this into a partial fraction, two partial fractions. So y minus 1 to the first power and also y minus 1 squared. So we're going to, I don't know what a and b are yet, so I'll write it like that for now. So just getting the format. But if I were to add these back together, then I would have to think about how to do that. So to get a common denominator, I would have to multiply this guy by another y minus 1. And b doesn't need anything multiplied by it because it's already got a denominator there. So my common denominator ends up being the y minus 1 squared. And my a plus b, I end up getting a times y minus 1 plus b. And remember, that is equal to our original fraction, which is 9y minus 2 over y minus 1 squared. So that must mean the numerators are equal. So that means a times y minus 1 plus b equals 9y minus 2. Now to get rid of the parentheses, I distribute and get ay minus a plus b equals 9y minus 2. Now I want to split it into these parts where I have the part with the coefficient, the linear term, with the y, and I have another part with the constant. So combining like terms, I only have one term with a y, so that's just a, but I do have the a and the b, negative a plus b for my constant. So the a equals 9 and the negative a plus b equals a negative 2. So a equals 9 is one of my equations, and my other equation is going to be negative a plus b equals negative 2. So I have a system of two equations and two variables. And happily, I happen to have one of the variables already solved, so I have a equals 9. So I can substitute that in here and get negative 9 plus b equals negative 2. So b, adding 9 to both sides, must be 7. And I'll take that solution and plug that into this format that I set up in step 1. So if a equals 9, I rewrite this as 9 over y minus 1. And my second partial fraction has the b, which is 7 over my y minus 1 squared. So there's my partial fraction. Final answer.